Hello everyone, this is a video lecture for pre-calculus. We're doing 7.3 polar coordinates. Alright, so let's talk. We have XY coordinates, which right now we're going to start calling rectangular coordinates. And our goal is to kind of go back and forth between that and r comma theta, which we're going to call polar coordinates, okay? R comma theta. So for example, let's say that they gave you 1 comma 2 and they said graph that. Well, you're like, oh, that's so easy, and you're just going to go bam, we're done with that. Boom. That was rectangular, true. But what if they said, hey, graph 1 comma 2 in polar form? You're like, what the heck do I do here? Well, my radius is a 1. I need to go to 2 radians. Where's that? Well, this is 1.5, so let's go, I don't know, somewhere out there. So this is right now 2 radians, and then I need to go a 1 distance. So let me just redraw this a tiny bit. Hold on. So it's like something like this. That's 2 radians. But I only want to go 1 unit out. So like this is 1 unit, but I want to go 1 unit out on the line here, on this line. And so that would be about right here, that same distance. So there you go. There's your answer. I don't know, point P, let's say. Point P. You can see that they're different, right? So this one ended up in quadrant 2. This one was quadrant 1. So just having 1 comma 2 is not sufficient. We need to know more about it. We need to be told, hey, this means, radians, this means polar, this means rectangular. So we have to be careful going back and forth now, okay? But that was just a small thing. We're going to get much more into this here in a bit, but the main idea is that you're going to go out some theta, okay, and then you're going to travel some amount of r, okay, along that path. So depending on wherever that r is going to be. Okay, so some formulas. These formulas you will be using again and again and again and again for the, I don't know, rest of your life. If you're a math teacher. But it would definitely be for the next few classes with us. Calculus uses this extensively. You'll just continue to see this forever. So x squared, y squared, r squared, x is equal to r cosine, y is equal to r sine, tangent of theta is equal to y over x. These 4 formulas are so super important. You'll be seeing them so often. So memorize them now. Okay, here we go. 7, 3, 1. They say we have 5, 45 degrees. Graph it. Well, it's kind of nice that they said it's degrees so we know. So 45 degrees is this line right here. Yeah, so that's my 45. They said go 5. So 1, 2, 3, 4, 5. There it is. We're done. There's my point, okay? Like the answer on my math lab would look like this. There's your answer. 7, 3, 3. I have -2 comma pi over 4. This one's a little different because it has a negative radius. Well, pi over 4 is, again, my 45 degrees. In fact, I'm just going to draw a solid. I think solids are going to be better than dashes. So that's my solid, 45 degrees. There you go, 45. But this time I'm going -2. And so it's the same line, kind of, but I'm going backwards. So -1, -2. So there's your final point right there, point P. I'm going to start doing point P to kind of just say, hey, there's my point. Point P. Okay, so I was looking at positive 45, but then I had to go backwards. I was walking backwards. In the classroom, I do like a demo of what this looks like in person. I can't do that on the recording, so I'm very sorry. Take my lecture class, if you can, at least. So I have -4 pi over 3. So negative means I'm going counterclockwise. And 4 pi over 3 is going to be over here. So that's -4 pi over 3. So that's my direction. But it says go -5. So I'm actually going backwards. I'm facing this direction, going back 5. 1, 2, 3, 4, 5. There you go. Point P, and we're done. Whew. 7, 3, 21. So here's another one. I've got, I should probably give you the point, 5 comma 2 pi over 3. So 2 pi over 3 is this direction. They say go 5 distance. So 1, 2, 3, 4, 5. There we go. And there's your point P. Okay. I think this last one's actually wanting more, though. And so they say find the rectangular coordinates. So finding rectangular is using those formulas. X equals r cosine theta. So r cosine theta. Well, I have an r, it's 5. Cosine theta is the 2 pi over 3. And so that cosine is going to be a negative 1/2. So negative 5 over 2. My y is r sine theta. And so I have 5 times the sine of 2 pi over 3. 5 times the square root of 3 all over 2. So 5 square root of 3 over 2. So in rectangular xy coordinate form or whatever, I want to do an equal sign, not an arrow. So I got negative 5 pi over 2. I'm sorry, just 5 over 2, sorry. And then a positive 5 square root of 3 all over 2. There we go. Cool. Apparently, let me turn the page here. Apparently. Okay, so this is the weird thing here. Let's just pause. On my math lab, and I was confused. This is a perfect opportunity to learn here. They have this point, they have this picture, and they say, find the coordinates that blah, 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 blah. I don't read. What they wanted were other r thetas that match up to the same point. Essentially, I'm looking for something up here in quadrant 2. Are there other r thetas that do the same thing? And so right now, what I have is a 5, 2 pi over 3, and they say, what else could that be? Like equal to, essentially. Same as a coterminal, that kind of stuff. Okay, so could I, like here, let's just go through the steps here. So to get to this point, I turned in this direction, and then I walked 5 spaces up. Okay, could I also, to get to this point here, I'm getting to the same point here, couldn't I go, I don't know, a negative angle and then walk forward? Sure. So that would look like my 5 distance that I'm walking forward, but then a negative 4 pi over 3. So again, I went negative to get there, but I still went a positive direction. So that's cool. Okay, let's do another one. Again, I'm trying to get to this point right here. Could I go a little bit down? So this is like where I'm in here. I'm going to do a solid line. This is where I'm intending to be pointing, but then I walk backwards 5. 1, 2, 3, 4, 5. Backwards. Yeah, so backwards 5. But now, where's this pointing? Again, that's a negative. Negative pi over 3. And there we go. So I pointed at the negative pi over 3 direction, but I walked backwards, so that works. Here's another one. Again, my goal is to get up here. So what if I, let's see here. I want to go backwards again. Oh, I know. Let's say I go all the way here. Okay. So I go almost a full circle, and then I walk backwards to get there. 1, 2, 3, 4, 5, etc. So definitely walking backwards, and then I got a 5 pi over 3 to get to that same place. Now, how am I gonna get all these every time? Like, in a way, I'm asking, how do I know to do positive, negatives, and all this other stuff, and to get the right answers? Well, I mean, really, just what I do is I look at it and I kind of just think about it. I know that sounds really bad, but there are formulas. I don't know, add 2 pi minus 2 pi, add a pi. I'm going to let you figure that one out, okay? I know you could do that. You find your own patterns. And that's a good thing. That way you'll remember them even better than whenever I tell you. So I'm going 45 degrees, pi over 4, and I'm traveling 5. 1, 2, 3, 4, 5. There's my point P in quadrant 1. So what else could I do to get to that point? So let's try some other stuff. What if I went all the way this way? Okay, so and then I went backwards 5. So I went backwards 5, but I went more than 45. What would that be over there? 7 pi? No. 5 pi. 5 pi over 4. Okay. Could I, to get to quadrant 1 again, could I go this way with my angle and then go backwards again 5 to get to P? So this would be a negative angle. So again, negative, and then I have a negative 3 pi over 4. Okay, or last one. I want to get the quadrant 1 over here. What if I went positive? I already did a positive. Let's do another negative angle. What if I went all the way around like that? And then I just went out 5. 1, 2, 3, 4, 5, positive. So positive 5, but I went negative 7 pi over 4. Okay. I know that you could do all this if you just add pi or, oh, that's a negative, by the way. If I add pi to it or add 2 pi to it or subtract 2 pi from it, try all those kind of combinations. Okay, next one. 7, 3, 33. It says I have 8, 270 degrees. It says find the rectangular coordinates. Finally, gosh. Okay, so this is easy. We had just done this a second ago. It's just that they weren't looking for it last time. X is cosine. Well, the cosine is going to be a 0, so you get a 0 out of that. It's kind of odd. And then my sine is a negative 1. It's negative 8. So then my point in rectangular coordinates would be 0, negative 8. There we go. Cool. 7, 3, 35. I have 1, 7 pi over 6. They say, go to rectangular form again. It's just repetitive. You know, it's not hard. It's just repetitive. And I hope that you're seeing that. I hope that you're seeing that the math, at least I know that's a little confusing up here. If you're a formula-driven person, this is driving you nuts. I get you, man. I get you. Okay? If you want to find a formula, then you do that. I know you could do that. Do it on your own. Okay? But like this stuff here, this is formula-driven. So if you like formulas, this is easy. Cosine at 7 pi over 6. You've memorized your unit circle, haven't you? Yes. Hold on, let me think about this one, okay? Yeah, it's negative square root 3 over 2. Very good. And of course, 1 times anything is itself. So then 1 times here, it's a negative 1/2. So my answer would be square root 3 over 2, negative 1/2. There it is. Awesome. Okay, the next one, 343, 7, 343. Okay, so they say that this is in rectangular coordinates 4, negative 4 square root of 3. And this is in rectangular coordinates. Now we're wanting to go to polar. Well, guess what? There's formulas for that. So here we go. Formula time. My r is equal to the square root of x squared plus y squared. Pythagorean theorem, that kind of thing. So I got 16 plus 16 times 3 if you distribute and do all the math there. So what you actually have is 4 times the 16. And so that's just 8. 2 times 4 is 8. Okay. My theta is the arctangent of y over x. Now, I have to say that this is actually a tiny bit incorrect. Well, maybe just misleading. Here, let me just keep going. So the 4's cancel, and arctangent of the negative square root 3, that's my slope. You wrote this down, didn't you? So my slope would be a negative square root 3. It's going to be one of these guys. And sure enough, well, that's the point, is that we need to just look at our unit circle. If you go and find this directly on a calculator, I believe you'll get a negative 60. Negative 60 degrees, which is fine. It's just that guy right there. But I want to know, basically 0 to 2 pi, 0 to 360. What's the real one? Well, notice that this is a positive x and a negative y. A positive x and a negative y. And so it is actually going to be here in quadrant 4, which is fine because that's down here. But if I had it flipped, then I would have to go quadrant 2. So just watch out for that kind of thing. To convert this over, we don't do negatives, of course, and we're not going to do degrees. That's going to be a 5 pi over 3. And so there's my answer for that. So my answer, my r comma theta polar, oops, I'm going to do equals. I like equals better here, not an arrow. Arrows say like you're working on it, but like we're done. So there you go. Close enough. Cool. Didn't I just do this problem? Like, I'm looking at the same problem here. Okay. So I got negative 4 square root of 3, and then I got a negative 4. They say go to polar. Whew. All right. R is equal to the square root of x squared plus y squared. Blah, blah, blah. Oh my gosh, it's 8. Who would have figured? Arctan. Again, this is a little on the misleading side. You got to be careful because as soon as I see this, I say, calculator, of course. But not this time, okay? So 2 negatives make a positive, 4 cancel, bring that up, rationalize, etc. This guy here is going to happen right here and right there. So my answer from the calculator is like 30 degrees. Or pi over 6, and none of that is right because negative. This is actually going to be a quadrant 3 answer, and notice that's why I drew it, because drawing it makes it correct. So quadrant 3, if I wanted to find out what this angle is going to be, again, it was 30 here, so what are we going to get is the 210, or rather, 7 pi over 6. There we go. Ta-da! Okay. How many more do we got? Well, at least we're getting to fun ones here in a second. Yeah. Okay. Yep. Okay. We're going to get to some fun stuff now. I actually do like this stuff a lot. It's just, it's so repetitive when they're saying, find the coordinate point. You're like, dude, formula, dude. Anyways, it says express as a function. I'm going to do function of r in terms of theta. So basically, they're saying find this function, not f of x. They're saying r in terms of theta. Okay. Now what my math lab has is simply r equals, and then we're just going to put some thetas inside. Okay. This is an absolutely awesome question. It's absolutely awesome to get wrong. I'm looking at the answer now. It is like so ridiculous. You should not have to do this like this, but you know, that's all part of it. It's just a fun problem. Okay, so how do I convert a rectangular, I don't know, equation into polar equation? Very simple. I'm going to plug in for x and y, r cosine theta, and r sine theta. That was it. It's a super easy problem now. What do they both have in common? An r. Leave behind 4 cosine theta plus sine theta, all equals 10. To get r by itself, you divide. And there's your final answer. This is what my math lab's looking for. So why is this a good one to get wrong? Didn't I say that normally I get things wrong? Like on purpose. Yeah, what I had done originally was I had seen this as like a radius, and then I plug it in, and it didn't work. Just, you know what? It's so wrong that I don't want to go back. I'd just rather do this. This is what you're supposed to do. Find x, find y, plug them in, and you're done. Okay. So the next one is the same style. We're converting into polar, and this is actually like so super easy. What you could do is say, well, this is r cosine theta, r sine theta, and go through all the mix. But if you notice that this is actually a formula unto itself, that is r squared. It's one of my formulas I have way up ahead, way behind me, I guess. Square root both sides, you get plus or minus 6. But thing is that with a radius of negative 6, let's just say here's positive 6, here's negative 6. Awesome. Same circle. Okay, same circle. So what they want you to do in my math lab is simply put 6. Okay. I know there could be so much more explanation for it, but it's just that easy. It is. Don't overcomplicate it, okay? Convert. Okay, this one is a little bit tricky. It's kind of interesting. So I have this y is r sine theta, and it's all squared, is equal to 11 r cosine theta. And so when you distribute the square, no, yeah, it's okay. You can do it here. Just don't make a habit of it, okay? I know some people see me like walking across a busy street where there's like cars all over the place and think, "Oh man, I could do that too," and then they get hit by a car. Don't do it. Don't do it, okay? Like, wow, Chad, that's an interesting analogy. It's okay to do what I do as long as I'm supervising you, and right now I'm doing that, okay? You could distribute the square as long as there's not a plus or a minus on the inside, but it's a very common mistake to do the wrong thing, so watch out. Okay, so I'm going to factor out an r, leaving behind an r sine squared minus 11 cosine, and I'm kind of puzzled. Like, I'm supposed to get r by itself, and I don't know. It just kind of looks weird. Like, I got an r here, and I got an r here. Like, how am I supposed to like get rid of one of those r's? What they do is tricky. They get rid of this r entirely. They say they do it because it's r equals 0 is the trivial solution. The trivial solution. I don't think they're actually saying that in my math lab because they're dumbing it down. But when you're trying to graph anything, what does your radius of 0 look like? It looks like a point. That's my radius equals 0. It doesn't really look like much. It doesn't really do anything. Hey, does this point right here, does that look like y squared is equal to 11x to you? No. What is this right here is a parabola doing this. So, yeah, that's not it. But the point is on there, so that's great. But it's not giving me the whole graph. So trivial solution, you actually just get rid of it, and you work with this side only. Again, are you allowed to do that every single time? No. I would say this is like a rare chance. But I'm supervising you and saying, yes, it's okay this time. Move it back over, divide. And there you go. So just watch out, okay? It is okay to do some of these more dangerous moves. But, you know, just have some safety gear on or something. Okay. I have 1, 2, 3, 4, 5 questions? Kinda. The other ones are GeoGebra, so they're a little different. So I only have 2 more of my Math Lab questions. Okay. 7,361. Okay, so it says theta is equal to 11 pi over 2. Convert. Well, that's, huh? What do we do there? Well, just, I was looking through how to make this thing work, and I have an answer eventually, but let's just see this. What if I did tangent of theta is equal to y over x? What if I did that? And so then I have tangent of the 11 pi over 2 is equal to y over x. What is tangent of 11 pi over 2? Well, it's a lot, so you need to like subtract 2 pi and all that stuff and whatever. Or you can go around like a bazillion times and wow, it's going straight down. Let's try that again. You go around a bazillion times and boom, straight down. So what is the slope down here? You would say it's undefined. Good job, good job. But now you're in calculus. Yep. Today I'm going to tell you it's negative infinity. Oh, what? And tangent is your slope. So I got negative infinity is equal to y over x. Sweet. I want to solve for something. So I'm going to take this and move it over. And so I got negative x times infinity is equal to y. Man, I love this math. I don't know when to spoil the secret. Move the infinity over. Negative, I guess. I don't know. This is just silly math. So yeah, your answer is 0. What? Yeah, kinda. So, okay, let's think about this. What if I had infinity in the bottom? Like, I don't know, 100 million billion. Something like this. Let me just kind of make this really, really crazy here. And you know what y is going to be? Y is going to be like a value like, I don't know, 5. Put like a 5 right there. 5 divided by bazillion billion. In the calculator, it's basically 0.00000000001. Round to 3 decimal places. It's 0. Very good. So negative x is equal to 0. You don't need the negative. So there you go. This is actually the answer. But if you went back up and you saw that, hey, it's going straight down, what is the graph of a vertical line going straight up and down? Going straight up and down. Well, it's x equals, and in this particular case, as x is equal to 0, instead of like 1, 2, 3, 4, or something on the side there. There's your answer. Whew, man. And you thought that I was doing some crazy math. Just don't show the calculus teacher. Even if it's me, don't show me. No. If you keep watching my calculus videos, you'll see me do some of that once in a while. So again, this is dangerous math, but I'm supervising you right now. Like, seriously, this is so dangerous. Don't do this, okay? In the real world, I'm just halfway playing with you a little bit. Okay, so it says convert this thing. All right. So when I was converting it, I actually went too fast. I was like, oh yeah, So like r is equal to the square root of x squared or y squared. Da, 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 da. Well, like let's just do the sign first, okay? Because I was going a little overzealous. What happens here is that you don't cancel r's, you move it to the other side, and then you start to factor. Now notice that I'm leaving my r's alone. That's supposed to be a plus sign. I'm leaving my r's alone. Now you can convert it if you want, but right now don't, so that I can factor it out really easily. What did I do? Well, I just put an R on there? Oops. Okay. Forget everything I just did. What was I thinking? I'll show you what I was thinking, but I was totally doing it wrong. I'm so sorry. Hey, guess what? Watch to the end. Yeah, I know you're hating me right now. I'm so sorry. Where did the R come from? Come on, guys. What was I doing? I was doing some dangerous math, right? Yeah. Yeah, okay, I'm sorry. That was just totally weird. Let's start over. So notice that sign. I'm going to convert the sign to y over r. That's better. Converting sign into y over r. Now this r right here is in the denominator, and I'm going to move them over here so I have them in my numerator. R squared is equal to negative 4y. Okay. Now I can convert this into x squared plus y squared is equal to r squared. And that, I think, is the answer. Yep, that is good enough for my math lab, and you are done. It's cool to see what's going on here. This is actually a pretty neat graph. It's a circle down here, and it goes until negative 4 on the y-axis. Y because of sign. But we'll see a lot of that later. Oh, never mind. They actually say what's the graph equal to. Well, there you go. We'll see a lot more of that later. But for now, just I would say that number is this number. Y here, so like, y-axis up and down kind of thing. Okay. Blah, 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 blah. So I have a GeoGebra question. I got 3 of them. This is the only big one, though. I feel like some of my questions here have been a little bit disjoint because I've been doing some crazy math once in a while. And then at the very beginning of this problem, I have so weird. Okay, so weird. So there's a graph, and there's a circle, and it's going up until 2, and so therefore it's centered at 1, and it goes here negative 1, positive 1, that kind of thing. It says rectangular and polar equations, note the x equals. Okay. So they're saying in rectangular form, we should have blank is equal to 0. And then in polar form, we're supposed to have blank is equal to 0. I really don't like this question. I don't. Like, what I did is I actually just got the answer by getting it wrong. And I'll just give it to you. So this is x squared plus y squared minus 2y is equal to 0, and this guy is r minus 2 sine theta is equal to 0. All right. I just really don't like this problem, and I'll tell you why. Because it's playing off the last problem where we had the sign was telling us what to do here. So as an example, I've got r times, let's just use a sine of theta. The graph for this is going to be up or down depending, as long as you got an a. Now if a is negative, it would go down, but sine means it's on the y-axis. Here's another version. Let's say I had like a cosine, let's just say. So cosine is x-axis, so it goes out until a. Again, if a is negative, it would go back over here. So those are some basic graphs. And I'm looking at this graph, and I'm like, you're going all the way to 2. And it's on the y-axis. I know this one. Like, it really, truly is that easy, okay? As long as you got the formula, you're good to go. But there's an x equal, or I'm sorry, a y equals, nope, sorry. It equals 0. And so I need to convert it to make it equal to 0. So I move this to the other side, and there you go. That's how we get that answer. So how do we get this answer? Well, I just take that and I roll with it. So there's a 2 sine theta, just like the last problem, and without making a mistake this time, I hope. R squared is equal to 2y. X squared plus y squared is equal to 2y. And then you can move this over because you must have it equal to 0. Oof. So many constraints. Just get a little bit upset sometimes. Just a little bit upset. Just a little. Okay. GeoGebra number 22. Okay. There is a line with 2 points on it. And so, yes, that's good. So right here, I have a point at 4, 5. And I got another point at -4, -5. And they say, find the rectangular and polar equation, blah, 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 blah. And I got an UG in my notes. I got UG. Okay. Here you go. Theta equals arctangent of 5/4. This is just the formula. This is a y, that's an x. Ta-da. Here's another formula for you. 5/4 and then times x. It's a proto mx plus b kind of problem. My slope is, well, it starts at 0, 0, and then we got 4 and 5, and, well, there you go. Not hard. Not hard. A little confusing. A little bit of, hey, is that really everything they wanted? Yeah. But not hard. Last one. They have a point A, and then they have a point B, and this is at 1, 1, and this is at 2, 2. And they say find the rectangular and polar coordinates. So coordinates, not equations. Okay, so that's fine. So yeah. The rectangular 1, 1, 2, 2. Oh, you're so smart! Great job! Yeah, I know I'm smart. Yes. Anyways, yeah, you actually do have to type those in. It is really silly. Okay, so how do we get these polar here for these guys? It's equally easy. So my r is square root of x squared plus y squared, right? Well, guess what we have here is 1 squared and 1 squared. So you get the square root of 2. Oh, and what's the angle? Just take a guess. What kind of angle would you have here? Just take a guess. Yeah, it's 45 degrees. Whoop, whoop. Yeah. And so how do you get out here to the 2, 2? What's your radius there? It's the square root of 8. You don't have to simplify. Yay! Yeah, you're done. Okay. That's it for this section. Thank you. Have a great day. Bye.